Nama saya adalah Syafiq Syamil Syakif bin Khairuddin dari kelas DIT 1 ni. Hari ini saya akan membentangkan tentang tugas PBA iaitu Subject Computer Architecture. Soalan pertama ialah Define Addressing Mode. The CPU determine the location of data or operation to be employed in an instruction using addressing mode. It establishes if the information in an immediate value a memory address or a register. Next question is question 2. List all the addressing mode in MC8000 processor. First, kita ada immediate addressing in this mode. The data value is given the target inside the instruction. For example, move #5 to mean the value 5 is moved straight into register D2. This mode is fast because the data is already included in the instruction. Second, we have a register direct addressing. Here, the data is taken directly from a register. For example, move D1, D2 means data register D1 is copied to D2. This is also very fast method since it doesn't use memory. Third, we have register indirect addressing. In this mode, the register holds the address of the actual data. For example, move A1 means the data stored at memory address inside A1 is moved to do. This is used when data is located in memory. 4. Index addressing this mode use a base address from register plus and offset value. For example, move for A1 means get the data from address A1 plus 4. It is commonly used to access element in array. 5. We have absolute addressing. Here, the actual memory address is written directly in the instruction. For example, move 2000 means take data from memory address 2000 and put into do. It's clear and simple but not very flexible. And C, we have relative addressing. This mode, the target address is calculated based on the current instruction location plus an offset. It is often used in branch or loop instruction. The last one is 7, PC relative addressing. This mode is similar to relative addressing, but it is the program counter PC as the reference point. For example, BEQ label means if the condition is true, the program jump to address relative to PC. This makes the code easy to move to other location in memory. In conclusion, each addressing mode has its own purpose and advantage. Immediate and register direct mode are the faster one. Index, absolute, and relative mode are more flexible. Understanding addressing mode is important from writing efficient instruction in a microprocessor.
Assalamualaikum and good morning. My name is Harid. Today I will explain question 1.3 and 1.4. Question 3. Give examples of M68000 assembly program that perform addition of two numbers using at least 3 addressing modes. First, use move.w to move #10. into D0. We use immediate addressing for this method. Second, we do move.w num1 into D1. We use absolute addressing for this method. Thirdly, we use add.w num2 into D1. We use absolute addressing. Lastly, we use add.w D0 D1 into D1 for data using data register direct. For question 4, give example of a MC8000 assembly program that performs subtraction of two numbers using at least 3 addressing modes. First, we do move.w val1 d0. We use absolute addressing for the first method. Second, we do move.w #3 into d1. We use immediate addressing. Thirdly, we use sub.w d1 into d0 for data register direct. Fourthly, we use sub.w val2 into d0 for we use absolute addressing. That's all from me. Thank you.
Hi and good morning everyone. My name is Nairawan and I'm gonna show you and present you question 1b. A student learn how logical and arithmetic operations are performed at the assembly level using the Motorola 68000 processor. The instructor has asked him to explain how basic logical instructions work in practice based on figure 1 below using easy 68K simulator. Okay. ORG. And now we're gonna run it. Okay. Right here, the ORG main origin 2000, which means it's gonna start at 2000. Move.w means 4-digit number in D1 is 4-digit gonna be in D1 at the back, which right here we have 4AB7 into D1. This line 9 is not .w D1, which only 4 number that we add at the back gonna be not gonna be changed. In line 10, move.w is the same like line 8, but it adds 5E92 into D3. For line 11, O.W, which is gonna compare 4 digit. It's gonna change into binary first, 4 digit at the back of D2 and D3, and it's gonna change to binary first, and then it's compare one by one. Okay, for the line 12 is add.w, which means 4 digit number of D2 and D3 gonna be plus and will be placed on D3. For sub.w is subtraction, which is minus is D3 minus D2, and it's also gonna the number that have been subtracted gonna be in D3 one digit. Okay, that's all from 1B1, and I'm gonna go for 1B. Okay, this is for the 1B2. List all logical and arithmetic instruction in M68K assembly language. For logical instruction, we have AND, which perform bit by bit and between two data, or perform bitwise or between two data, or perform bitwise exclusive or one if bit differ. Not inverse flip all bits of a data. CLR set a bit in operand to 0. CLR is clear. TST test data for 0. Set condition flag only. BIT BAST is bit test. That's a single bit in register or memory. BCHG to toggle flip a specific bit. BCLR clear a specific bit. Set it to 0. BSET is set a specific bit to 1. Okay, for the second one is arithmetic instruction. Add is add data to another data. Add ADDI, add constant number to a data. ADDI is add immediately. ADDA is add address, register content. ADDQ add small constant 1 to 8 quickly. SQB is subtract data from another data. SQBI is subtract immediately, which subtract constant number from another data. SQBA is subtract address register content. SQBQ fast subtraction of small contents. MULU is answer multiplication, which 16 times 16 is 32 bit. MULS is sign multiplication. DIVU is unsigned division. DIVS is sign division. NEG is negate, which replace operand with it to complement. CLR is set operand to 0. CLR is clear. CMP is to subtract for a flat setting, no result is stored. EXT extend byte to word or word to long word. ADDX or SUBX include the X flag for multiple precision arithmetic. ABCD or SBCD is for BCD decimal arithmetic operation. Okay, that's all from me. Thank you.
Assalamualaikum. My name is Zahirul Ashraf and I'll be presenting question 2a, which asks convert the expression below into an assembly language instruction. And we have the formula 10111111 base 2 times DADA base 16 plus 1234 base 8. So we first have to do origin 1000. Then we move .w 10111111 to the 0. We use percentage because the value is in binary. Then we do move.w hashtag $ DADA to D1. We use $sign because it is in hexadecimal. Then we do move.w hashtag at 1234 D2. We use at because the value is octal. Then, after we moved all the values into the data registers, we then do mulu.w d0 d1. So we do 10111111 times DADA. After that, we then do add.w d1 because the value of the previous multiplication is stored in d1. Then we add d1 with d2, and then we do end because we're ending the program. That is it. That is all from me. Thank you.